we did the octahedral for octahedral complexes, right? We saw the crystal field splitting for octahedral complexes. We did the orbital diagram for octahedral complexes. Now let's come to tetrahedral complexes. Tetrahedral complexes is just the inverse of octahedral complexes. In octahedral complexes, if you remember, the ligands they approach towards the axial orbitals of the metal. In case of tetrahedral complexes, the ligands they come towards the non-axial orbitals of the metal. So the non-axial orbitals they get raised in energy, whereas the axial orbitals they get lowered in energy. Here you can see in this diagram. In this is the d orbital of the free ion when there is no metal present, or when there is a metal present but there is no ligand present nearby. Then when the ligand comes from far away, then all of the d orbitals they get excited equally. So all of the d orbitals are excited equally. Then the ligand, when it comes closer, it can be seen that it is approaching towards the non-axial orbitals. So the non-axial orbitals they get increased in energy, and the axial orbitals they get decreased in energy. So this entire difference is known as del T. For octahedral complexes, if you remember, it was del O. For tetrahedral complexes, the difference between T2 and E is del T. For tetrahedral complexes, you will no longer use the subscript G. It will just be T2 and E. For octahedral complexes, it was T2G and EG. For tetrahedral, it's just T2 and E. So the tetrahedral, that is the T2 orbitals, you can see that they are increased in energy by 2 by 5 del T. Whereas the E orbitals, they get decreased in energy from the average energy by 3 by 5 del T. This is again the barycenter. So if this is the barycenter, then that's the average energy of your d orbitals. Now this is a question. It says that relative to the average energy in the spherical crystal fields, the T2G in the octahedral field is. We know that the T2G in the octahedral field is lowered, right? EG and T2G. This is for octahedral field. And if this is the average energy, then the T2G it gets lowered by 2 by 5 del O. So the correct answer is lowered by 2 by 5 del O. In the same case, if it would have been asked that relative to the average energy in the spherical crystal field, the T2 orbitals, if it's asking T2 orbitals in the tetrahedral field, what will happen to them? Then you will answer that the T2 orbitals in the tetrahedral field, they will get increased in energy. That is, they will be raised by 2 by 5 del O. Not del O, they will be raised by 2 by 5 del T, because del O is not a parameter of your tetrahedral complexes. Del O is a parameter only of the octahedral complexes. So this is a question for octahedral field. So that is why del O, del O, del O and del O is written. If the question was for a tetrahedral field, instead of del O, we would have del T here. And then the correct option would have been raised by 2 by 5 del T.